Okay, so the story of selection sort, which is another quote-unquote simple sorting method, is that we're just going to sort of scan through the list that we're given, find the minimum value. In this case, that'll be 11, right? And then we're going to swap it to the front. And so the next step in this selection sort, the list we have will look like this. 11 is perfect. We're done with it, right? Because it was the smallest thing, therefore it goes in the front. And so now we ignore that part of the list and we just look through the rest of the list for the minimum. And at this point, the minimum in the rest of the list is this 14 here. We can then swap 14 with 88 to sort of put it in the front of the list we care about. And now we get something like this. And so 11 and 14 are sort of frozen now. And so we look through from 35 to the end for the minimum. And in this case, the minimum is now 24, right? And then, so we'll swap that with the 35 over here. And that will give us a frozen 11, 14, and 24. We once again go hunting for the minimum. That'll give us 27. We swap 27 with 47 here. And then we will have 11, 14, 24, 27. We're halfway done, or almost halfway. I'm going to speed up here, where we have 35 is now the minimum. We'll swap it with 88. The next time through, 41 will be the minimum. We will again swap it with 88. Right? Here we only had to look through 4 things to find the minimum. Now we only have to look for 3 things to find the minimum. In this case, 47 is going to be our friend. And then we now have all but the last 2 pieces frozen. And so it turns out we only have to do the loop looking for the minimum and swapping it to the front one more time. In fact, 62 is already in the right place. And so now we're done, right? There's only one piece of the list left. And turns out it's, by definition, if you only have one thing, it is the minimum. So we're good. Okay, so how does selection sort work? Well, we sort of say, like, for start in range, length, list, something like that. And then position equals find min list start plus 1, right? We look for there to start to the end, something like that. And then we just call swap position start. That's the whole thing, right? As start moves to the right, that's sort of like our greenness here, right? So at the beginning, start is 0, and so the whole list we care about to search for the minimum, we're actually looking over here. Maybe I'm wrong. Maybe it's not plus 1 in here. Because we include start as the potential minimum. Yeah, that's right. And so each time we go through, we have smaller and smaller of a list to work on, right? So the first time we have to look through n elements to find the minimum, and then n minus 1 elements to find the minimum, then n minus 2, so forth. And so this sum is the same thing as, basically, we don't actually have to do any work when there's 1 left. 2 plus 3 plus 4 plus 5, all the way up to n, which is going to be roughly n times n minus 1 over 2 minus 1, which again is just big O of n squared. And so selection sort is a nice, sort of fairly straightforward sort, especially if you go ahead and write a method called find minimum that takes a list in a start position, sort of slice of a list, if you will, and gives you the position of the minimum element.